got all our three amazing panelists on the
Yes.
screen. I just wanted to say thank you, Robert, thank you, Jess, thank you, David. Each of your talks was spectacular and just from such different areas that it was fascinating that it all uses network science as a tool. In fact, Sevvandi, if I may, I might just want to ask each of the speakers a very general question. How did you end up using network science for your research? Was it a natural consequence of the problem that you were researching, or did you actually want to look at the problem from a network science lens for a specific reason? And I know, David, you touched on it a little bit, but I'd like to hear from everybody how you ended up in network science. Rob, would you like to go first?
Okay, thanks. I have a story to tell. I'll try not to bore everyone, but yeah, so as Asha mentioned in the introduction, my background's economics, and so however, my PhD, which was on index number theory in the context of cross-country comparisons of living standards, actually used graph theory because shortest path algorithms actually were part of so I learned a bit about graph theory during my PhD, but I had no idea what social network analysis was because my training was all in economics. And then, so in around 2001 or 2002, I started moving into this new area, which is the area I'm in now, which is studying online behavior. And I was interested in visualization. And I started studying hyperlink networks, and I produced some networks there was one, for example, with pro-choice and pro-life websites, and there was a very strong clustering on the basis of whether they were pro-life or pro-choice. And there was a sociologist at the ANU, Al Klovedal, who was a social networks, quite very prominent in the area of social networks. He said, oh, that's really interesting. That's homophily. And I hadn't really heard of the term. Anyway, that was when I realized that what I was actually doing was studying online networks using social network analysis. Prior to that, I'd been mainly influenced by the information retrieval literature in computer science, which again, so I was coming across network concepts, but I then realized that there was this huge field of social network analysis. And in 2004, I met Gary Robbins in Amsterdam. So Gary Robbins, who helped founded Melnet, and also obviously a very prominent network researcher in the area of exponential random graph modeling and other areas. And I met Gary in 2004, and he, in his very typical modest way, said, oh, we do a bit of network analysis. We do network analysis at University of Melbourne. Come down and chat with us. And then I kind of found out that they were doing a huge amount, and they were internet, and so it's just that I was not in that field. So I came into social network analysis kind of through a I just came across it, and I realized that's what I was doing. So that's my journey. I'll hand it over to someone else.
Thanks, Rob. How about Jess?
Yes, sorry. I think, oh gosh, I can't even remember when I first, it's a few years ago now that I started looking at networks, but I guess it all started with me doing a vacation scholarship at RMIT, actually, together with Asha. And we were looking at money laundering. So we were, I guess that was kind of my first introduction to research, and that was, I mean, Asha, with her background, obviously was interested in money laundering. I can't remember how exactly we arrived at network science, but I guess it was going like we looked at papers, and I guess this what David talked about, like criminal networks before as well, where we kind of realized, oh yeah, there's nodes and edges and connections between them. And then I did my bachelor in mathematics, so obviously I had this graph theory background as well a little bit, and I think that's kind of where I made the connection and thought, oh, it might be interesting, to dive deeper into network science. And I think Asha at that time was becoming more and more interested in that as well. And then we kind of, yeah, the vacation scholarship kind of then evolved into an honors, and then I continued on doing a PhD. And I mean, I wasn't looking at money laundering anymore, but it was then, yeah, fully network science, because I became so interested in it and kind of realized that there were a lot of gaps that I would like to look at. So for example, with my PhD, I was looking at bipartite networks, where you have two different kinds of nodes. And that was something that I started to realize during my honors, that there's not a lot done in that domain, that most of the network measures are focused on just ordinary networks, I guess, where you have one type of node. But that bipartites are kind of a special case. And yeah, that was, I guess, my way, how I got involved with network science.
And now you're using it in epidemiology.
Yeah, it kind of evolved from there. I guess it's a really useful skill to have. I feel, yeah, after my PhD, when I was looking for postdocs, yeah, I think a lot of people in epidemiology, in, you know, large like data analysis, big data, they all look for network science. So definitely helpful, yes.
Thank you, Jess. David, did you always use network science, or did you choose it because of criminology?
Well, I chose it, and I also kind of chose criminology. So really briefly, my background's in psychology, and when I finished my undergraduate degree, I worked in mental health and prisons for about 10 years, and then did a PhD on jury decision making in forensic psychology. And then in my postdoc, I got a postdoc working at the National Drug and Alcohol Research Centre. And I was drawn not so much to the health component of that work, but more to the sort of drug trafficking, organised crime component. And I started doing some work on drug trafficking, not networks. But then when I started reading about networks, I could see the value that it potentially had for understanding how these groups operated. And I think I was drawn to it particularly because I could combine the sociology that I really enjoyed working in the drug trafficking space with the psychology that I had a background in. So that sort of combination was really attractive. And then it just kind of went from there. I too, bit like Rob, I met one of the big guns in the criminal networks field, Professor Carlo Morselli, who sadly passed away last year after a battle with cancer. But he was really influential, and, you know, was really encouraging. And at a time when I was just a sort of fledgling researcher in that space, he was particularly helpful, not just in the concepts, but also in just encouraging us to push through some of those data problems that I described at the back end of the talk today. So yeah, so it was a choice. So I chose both network analysis, but also kind of chose criminology as well, because I then sort of moved away from psychology and more into sort of criminology, and again, attracted to that sort of combination of social factors, but also individual level factors.
Arathi, Ben has a question.
Hi, thanks for all the talks. I've tried to listen to the last few while driving, so sorry if I've missed something. Just a quick question on what you think of the future of predictive power of network science. And I say that because of, for example, the criminology, which I find fascinating. But I have
here after.
Sorry, can you hear me now?
Yeah, because you dropped out a bit, like you said, the predictive power, and then I didn't hear the rest. Maybe the others did. I don't know.
Right. So my question is generally what the panelists feel about the predictive power of network science going forward. And just because I was thinking while listening to the criminology talk about the problems with the terrorist networks and terrorists, because terrorism is a very rare event, and it's very easy to get a very big network, so you have a very high noise to signal ratio. So I'm just curious about what you think of the predictive power of these things in your various fields.
Do you want me to go first, given the question?
Yeah. I was primarily interested in what you were saying, but yes, thank you.
Yeah. Look, I think that the short answer is, yeah, I think there is a lot of predictive power in networks, but I've always been interested in the idea of combining social network analysis with sort of an agent-based modeling and looking at the combination of those two types of analyses for that kind of predictive, the predictive power of those two analyses combined. Because particularly in the terrorism space, where you're looking at not just what groups are doing and how groups are behaving, but also individuals, particularly with that idea of the sort of lone actor idea. We've just finished some work that we should be publishing on soon. There's not a lot I can say about that because I think it's still somewhat under embargo, but broadly speaking, we use social network analysis to look at radicalizing factors in networks, but also protective factors in networks. So I think there's value not just in identifying what's going wrong, but also in identifying how things might be counteracted, how you might protect individuals from becoming radicalized and from going down a path of engaging in terrorism or organized crime or whatever it is. So looking at what kinds of protective factors networks can instill in actors in that space.
Thank you, David. Rob, would you like
to... Excuse me. So the area that the areas that I apply network science to, some of the challenges that we have with regard to prediction are that, one of the challenges is that a lot of the struggle that I have with colleagues who are interested in, for example, misinformation or how digital platforms might be changing people's engagement with the way they engage with information, how it changes their opinions, for example. I think it lends itself very naturally to network analysis. And that's why, for me, network analysis is a kind of a key part of the toolkit, because these are networks, and I think that they are people who are, we can represent their behavior using network approaches, like network methods, like what I was demonstrated in my talks today. But a big challenge is that, say, unlike the networks that David has, so David, obviously, in the area of the research that David works on, there are huge issues to do with data availability because of the nature of the actors that are being studied. But at least with the data sets that do become available, you're kind of, what the nodes are. These are people who are, have been identified as criminals or terrorists, and you know what the connections are between them. But I'm sure that, yes, there are lots of other missing data issues that need to be addressed. And so I'm not saying it's easy, but one of the challenge, I have similar kind of challenges, but the challenges are different in the sense that, like, I don't even know who these actors are on Twitter, and I don't know whether they're real people, are they bots? And I don't know whether it actually even matters in some ways. The other thing that I know it matters, but it's hard to know exactly what to do about it, these data limitations, but that comes hand in hand with studying social media, and especially because I'm interested in studying sort of public discourse on social media. My starting point in the research is not a set of actors that I've pre-identified, like, for example, advocacy organisations in Australia, and I study their Twitter accounts. There are some people for whom that the research, that design works for them. And then in some ways, network analysis kind of makes it easier because you already have a predefined boundary around the actors. It's a set of actors that are, for example, advocacy groups, and you want to know how they connect to one another or how they advocate issues using Twitter. my interest is in actors who are not necessarily that. Yes, some of them, they may be advocacy groups, but they also might just be someone in their living room who's gotten interested in anti-vaccinate, contributing to dialogue about anti-vaccination. So it's a much more heterogeneous set of actors. And as I said before, you know, we don't know much about them at all. It's all we know about them is what they do on social media, and that's just the nature of the problem that I'm interested in studying. And so I'm not. But it does kind of limit you in terms of the sort of approaches that you can use and what you can actually in terms of your predictive abilities, the ability to predict behaviour. So that's, you know, and just to finish off on this sort of same theme. I mean, again, I could go on for quite a long while about this, but the Reddit network that I presented today, the conversation network, I don't even regard that as a social network. It's a conversation network, and that's different to a social network. A social network is a network where you have interactions between individuals, and where there is some kind of, the connection between the individuals means that there is some form of interdependency between them. And therefore you understand how they may be influencing one another because they are friends with one another or they are peers with one another. The networks and that's what social network analysis is being designed to study, those sorts of data sets. And even with a really well-defined friendship network data set, temporal friendship network data set, you've still got a whole raft of very challenging problems that people in social network analysis are working on. But my challenge is that I don't even believe the Reddit networks are social networks. They're not. They're just people going in and commenting directing comments to one another. Half the time they don't even know, they're not even responding to a person. They're responding to a comment that someone has written, and they may not even know who, you know, the identity, I mean the Reddit handle of that person. So these networks are massive, and so it makes it challenging to kind of just take social network analysis approaches and apply them to it. And so that gets back to this, I guess, this whole challenge about, well, the limits of network analysis, and how in the area that I'm interested in, which is opinion formation, or one of the areas I work on, we're interested in studying, well, to what extent, how far can we go with social network analysis, and where do we need to be drawing upon from other areas. So I'll leave it there.
Thank you, Rob. And Jess, how about your thoughts on the predictive power, especially?
Yeah. So I guess like my area, the same. I mean, we do use network analysis, but we do use it in combination with other things. David already mentioned agent-based modeling. We're looking at that, how we can combine that. Also Bayesian statistics. What else? Probability theory. So I guess it's a combination. It's not just network science by itself to predict something. And while we're talking about challenges, I guess in my case we're looking at disease data. I mean, we're very lucky for example, with the dengue data set, it's complete. It's everything that's been reported to Queensland Health. But the thing is, not everything is reported, right? So I mentioned that during my talk, there's a lot of cases that are asymptomatic. People might not go to the doctor because the symptoms are so mild and they don't realize that they do have dengue, but they could still transmit the disease to other people. So that's actually one thing that we're looking at. We're looking at the degree of underreporting. Because we know it's very high for dengue and for coronavirus as well, looking at both at the moment. So yeah, that is a real challenge. We've got these great data sets, but we also know that diseases are underreported, but we do not know to what extent. And I think that's really, yeah, it's really difficult to predict what that is, because again, if you come up with a model that predicts underreporting, then the question, how do you validate that, right? We just, you know, we don't have anything to compare it to. So I guess the best that we can do at the moment is to create oh gosh, missing the word. Synthetic data sets, that's what I was meant to say. And then kind of, apply some sort of underreporting to those, and then see if we can recover that with the predictive measures that we've got. But yeah, it's definitely not just network science that we're using. It is definitely a combination of network science and other statistical measures as well, methods or machine learning, probability theory, all of those. So.
At that point, I've got, like, I was going to ask that question. So of the work, because like Rob is doing one application and David is doing another one and Jess is doing another, three different sides of network science. So of the things that you're doing, how much would you say is, like, you use network science, but also other tools, and these other tools and other areas of science and social sciences and all that, like how much is there of, what's the combination like?
Do you want me to go ahead or?
Yep. Yeah, you can start, Jess. Yes, yeah.
Yeah, so I feel in my case, network science is really the base to all of this, and then we apply other things on top, and I think it really depends on the problem. So I've been working for quite a while on predicting the number of dengue importations and COVID importations as well into Australia. So the network science in that case is coming from flight data. So we've got data from IATA, and I always forget what exactly that stands for, the International Aviation something. So that's basically a data set of airports and the number of passengers traveling between those airports. So we've got that for a couple of years. So that's a huge, global, worldwide network aggregated on a monthly basis. So this is kind of our foundation that we're working with, and that, we're creating a network from that. But then on top of that, we're looking at incidence rates in other countries. What is the probability that someone who's overseas is getting infected? So we're looking at how long is this person staying in that country, all these different things. So it's hard to quantify and say how much network science, how much other areas are coming into this. But I feel, at least in my case, the network science is really the base. And as I said before, like the disease networks and mobility project, and that all of this is part of, is really focusing on human movement and how do humans spread diseases. So it's the mobility, and that again it's networks. So we're looking at mobility data and looking how are people moving between regions and how does this influence disease spread. So I think it's really this foundation layer that's the network science, and then everything else is kind of on top, and that really depends on the problem that we're looking at.
Yeah, what about you, Rob, and then David as well?
Yeah, my answer is actually quite similar to Jess's. I mean, I feel that for me, it makes it easier to think about the world as a network. I think it makes sense given the behaviour I'm interested in. It's on digital platforms, and it's network. People are discussing things on digital platforms. I think it makes it easy to think of it as a network. I mean, Facebook is described as a social network, or it is kind of close to a social network, although I can't get Facebook data anymore, like anyone, just like everyone else. So I think it's natural for me to think about the world I'm interested in studying as a network. And that's what really resonated with me when I sort of encountered social network analysis, formally as a field. And I thought, okay, that's what I'm trying to do. Because up until that point, I mentioned earlier on, I had been influenced by the sort of more the information retrieval literature. And I knew about graph theory through my economics in my PhD, but I'd also encountered something that took me a long time to come even further to grips with, and I'm still struggling, but actor network theory, which is sort of another way of thinking about relational behavior in the world from networks, but it's actually very different. So this is the work associated with Bruno Latour, and I guess its origins are in science and technology studies. So my initial encounter, when I first studied studying hyperlinks, I actually encountered Issue Crawler, which is a software for collecting hyperlink networks, but it was actually Richard Rogers is associated with that work, and it was very much coming from an actor network theory perspective, and it didn't resonate with me at the time, and so I sort of, but social network analysis did. But anyway, the point I was trying to make is that I think about the world as in terms of networks, but I'm also conscious of the fact that just because you can represent something as a network doesn't mean it is a network really, or that the actors involved in it, or that it doesn't necessarily mean that it gives you sort of analytical purchase in terms of being able to understand outcomes and behaviours. So I try to be careful to not, just because it's relatively easy for me to construct networks from the data I collect, I try to be open to other analytical approaches that might make more sense. So for example, I don't just sort of run everything through an exponential random graph model, even though I could represent the networks in that way and run ERGMs, I don't always do that. I try to be careful. So to choose approaches that make sense given the problem at hand. So I guess this is a long-winded answer to say I find it easy to represent the data as networks, but then after that, there may be other techniques that make a lot more sense in terms of and understanding behavior. So for example, I'm interested in causality, like how does one actor's behavior maybe influence another actor's behavior? And so in terms of their, what they're tweeting about, for example. And so for that, I'd be kind of turning to sort of some of the econometrics techniques that I learned years ago, like Granger causality. And that isn't, that's a time series statistical approach, but it's something that I can use with the dynamic network data that I've generated. So I guess I try to be as open as possible is my summary.
Yeah, I guess just briefly, maybe I'll just expand on what's already been said. I mean, my approach is very similar to both the other panel members. So, I mean, just to give a couple of examples. So in terms of, data coding and data collection, I mean, much of our data comes out of narrative data or qualitative data. So we're transposing, I guess, some data that comes to us in narrative form or qualitative form into quantitative form to represent actors and ties. But then we've also combined the use of social network analysis with approaches like crime script analysis, which is a way of breaking up a crime into its sort of elemental units, or what are the activities, what are the resources that are required for a particular activity to occur, and then looking at how you can overlay that with network data. So which actors are involved in which points, and how do those actors connect with actors who are in the same kind of crime scene and with actors in different scenes across the script. But as I sort of alluded to in the talk, we've also used social network analysis, but then built on top of that computer simulations that are using social network metrics, but also incorporating other types of, I guess, decision-making steps within that modeling that combines SNA with these other types of computer simulation techniques.
Yes, thanks so much, David. I think we need to wrap up now. People have asked here, Jason has asked, are there any plans to get back so because at the end of David's talk, we were kind of running a bit behind time. So, and then so Jason has asked, are there any plans to get back the unanswered questions from the last session, or should I email the speaker directly at this stage? So is it okay if we, because this is mostly David's questions, we couldn't get through all the questions. And because I jumped in and asked a couple of my own questions as well. Is that okay, David, if we ask people to email you directly?
Absolutely. Very pleased to receive any comments, feedback, questions. So yeah, sure.
Yes, yes. So there you go, Jason. Yeah, I think we should wrap up because now, we've already gone over time. Thank you so much to our speakers, all the speakers, Rob, Jess, David, and also Steve and Joel. And, thank you so much. Yeah, really great session on today. The talks we've really enjoyed, and you can see that from the questions. And, yes, thank you very, very much.
Thank you. Thanks for organising this and for inviting us along.
Yeah, it's been great. So thanks very much. It's been enjoyable. Thank you.
Thanks a lot. Thank you, guys.
Bye-bye.
Thank you. Bye-bye.
Have a good evening.
Yeah.
Have a good evening.